the start of this, right? So locomotive, you've got the mass of the locomotive, you've got the mass of each car, and accelerates from rest to 2 meters per second in 5 seconds. So the first thing that you're going to find in this question is the acceleration. Okay, so you've got V2 minus V1 over delta T. Okay, now we find all force the same way, right? We find net force equals mass times acceleration. Okay, so now you have to determine where the amount of mass that's being pulled by the rope. You ignore everything in front of the rope. Now you have to find out how much mass. So your locomotive is right here. All right, and you're pulling how many cars? Says
20 cars.
You got 20 cars, right? So the mass is 20 times whatever the mass of one of those cars is, and that gets you your force right here. Okay? Now when you look at the rope between car 10 here, how many cars are over here then? If this is the 10th car, how many cars are left? 10. So then it's 10 times the mass of the cars.
Oh, okay.
Okay? And the acceleration is always going to remain the same. But the important part is just determining what is the mass that that force is, that tension force, the coupling is actually pulling. Okay? So you can, I think, do that from there. Okay? Other questions today?
Number 1 on the same page, 147.
So you have a force, 360 newtons for a time of 0.1 seconds.
Okay.
Yeah?
Yeah.
So the action-reaction force, the time is negligible right now. We don't need to worry about the time at this right now.
Okay.
Okay? So you're pushing this block this way with a force of 360, and you're pushing this block with a force of 360. So then it says, what is the girl's acceleration? So how do you get acceleration?
Do algebra. You have
No.
force.
Yep.
You have the acceleration. No, not acceleration. You have the mass.
Yeah.
You need the acceleration.
Right.
So you just substitute.
Sure. Can you do that?
Yeah, I can do that.
Okay, that's all you
What was I
need.
doing? What was I doing wrong
Okay. And then you need this after
here? Yep.
with this, and then you can get your that.
Okay.
Okay?
I sure butchered that question because I went way off into the woods.
You okay then, Morgan?
Yeah, I'm okay.
Alright. Any other questions today? Kelsey?
On legend, on the next page, 150. I got 1800 newtons, but it's supposed to be 9. I don't know.
22 calories a bullet, mass 1.8 grams. Shoots the muzzle velocity of 500 meters per second. Okay, so the trick in this question is to know whether or not the muzzle velocity is V1 or V2.
Oh, okay.
there'll be two types of questions like this. One, the muzzle velocity would be the V1, in which you're calculating everything after it's out of the gun. But when you're calculating it within the gun, your muzzle velocity is your G2, because your initial is that,
Okay.
okay? Does that make sense?
Yeah.
So then you've got, and then you can calculate anything you need from that point on.
I just did change in velocity was 500.
Yeah. That's fine.
Yeah, will it work that
Yeah.
too?
Yeah. Did you change the kilograms?
Yeah.
Okay. And your barrel is 0.25 meters?
Yeah.
Alright. So, you probably did it right then.
Okay, because my force turned out.
They rounded. They rounded off an 11. They rounded to 900. What did you get your force cents?
1500.
Well, then that's off by quite a bit. So just check your math again.
Okay.
Okay? You got V2 squared equals V1 squared plus 2AB to get your acceleration.
Okay.
Okay? Anybody else today?
Number 4 on page 143.
133?
143.
The incline question?
Yep.
One we did yesterday? On the board? Morgan?
Yeah, that's the question, yeah.
This is why we have to stay awake in this class, Morgan. Alright. Take 2, is that what you're saying? Mm-hmm. What's the first force acting on this, Morgan? Just look at the board, Morgan. Tell me what the force is that's acting on this box. What's the first one we always talk about?
Normal force.
Well, that would be the second one. Let's start with the first one. What's opposite of normal usually? What is acting on you so you're not falling out of your chair right now? How come you're not floating around this room?
What's the word? Gravity.
So it works straight down right here. The force of gravity is 20 newtons. Yeah?
Right.
So the chair underneath your butt is pushing you back. That's called a normal force. It works perpendicular to your surface. So that makes a right angle right there. Okay? So this is your normal force.
Yep.
You're okay? What direction is this box going to move?
It's gonna move down. It's gonna go down 20 newtons.
No. It's on a hill. It's not gonna go down. It's gonna slightly go down.
It's gonna go back.
No. Let's try this again, Morgan. Which way is it gonna go, Morgan? I set this on here. Which way is it gonna go?
It's gonna go down. It's gonna slide down.
Slide down in which direction? Is it gonna fall straight down to the floor?
Nope.
How would you describe this to me?
Decline.
Okay,
Incline is up. Decline is down.
alright. Okay, so if I let go of this and it stays on this ruler, what's gonna happen to it?
It's gonna slide downward.
Okay?
Slide
Can it take the
downward diagonally.
Right, okay, that's the word, that's the start. Okay, diagonally is right. parallel to my actual slope, right?
Right,
It moved parallel to my slope.
yeah,
You agree?
mm-hmm,
So that's this direction.
Yeah.
Okay, that's my applied force. Now I'm just gonna draw that same vector down here now. Okay, so this is my applied force down here.
Yep.
All I'm doing is drawing a triangle so that I can solve it now. Okay? So I've got my force gravity, I've got a right triangle right here, right?
right,
Now I need an angle. Well, this is 15 degrees. That makes this 15 degrees right here. This angle and that angle will always be the same thing.
yeah,
Okay? You have to remember that.
yeah,
So the angle of the incline of the hill and that angle right there are the same. Where is this in relation to that angle?
it's opposite,
Where is this in relation to that angle?
Opposite. Or,
You said this was opposite.
yeah,
So that can't be opposite. Let me draw this a little bit better for you so it's easier for you to see. Where is this in relation to that angle? Where is FA in relation to 15?
it's opposite from each other, I'm pretty sure.
Where is FG in relation to 15?
So hypotenuse, it has to be, it's adjacent.
What is that then?
Well, that's the hypotenuse, the other side is adjacent.
Okay, so what am I talking about? I got opposite and I've got hypotenuse. So what am I talking about?
Opposite and hypotenuse, that's sine.
There, that's all you need to solve for FA.
Okay.
You good?
Just the part about the parallel, I may mess up on. And making the diagram is another thing too. I guess if it says, if it's an incline, think of a hill or the ruin.
That's what it is. This won't change. It doesn't get any harder than this. This is the way it goes.
Yeah,
We're gonna add one thing to it in the next section, but for right now, this is all you need to know. So there's only one thing that we could change in this section, and that is, what would be restricting the motion?
something pushing it,
Like what?
a hand, a
Hey,
vehicle.
there's no,
But there's nothing there stopping it from going down, it's gonna slide down anyways.
Is it gonna slide forever?
Nope,
How come?
because that curve, or not a curve, that hill, that diagonal may end.
What if that diagonal doesn't end? Is it gonna go forever?
Yes,
Think so?
yeah. I'm wrong?
Yes. Morgan, what acts on everything? How come that book isn't sliding off your desk right now? Well, poor example.
The books are sitting here because something's holding it,
What's holding it?
the table,
Yeah, but why is it not sliding off?
because it's sitting on something flat.
If I push it or I move it, why is it not sliding off? If I put it in an incline, why is it not sliding off? You know what that is, Morgan?
Final force,
No.
front force,
No.
friction.
Friction not affecting everything we do?
Yeah, it's affecting everything we do, but that block has no friction.
No, not in this question, but what happens, that's what I'm saying to you, if the question changes, that's the only thing I can add to the question, is a frictional force,
Yeah,
which has to work opposite of what my applied force does.
yeah,
So it acts as if it's pushing it up the hill. Do you follow what I'm saying?
yeah,
Okay? Force of friction, we take into account on everything unless it says a frictionless surface or a smooth surface. Then we assume that there's no friction.
yeah.
Follow that, Martin?
Yeah.
Good. You got that down today?
Knowledge of it, yes.
Have you written it down?
I did have this question written down, I didn't realize it.
Alright, Morgan, we're done with this question?
Yeah.
Alright. Anybody else have anything today? Okay. Rest period to work with.
And are we allowed to use it?
Sure.